Hey,
Hey,
May. Didn't
hey,
see you for
May.
a long time. Hey,
Long,
mate.
hey, May. Long time no see.
Yes. Yeah. Let's
Let's
start
start
the
with
second.
episode 2 of Seb and Julian and Seb. Why Flutter great, right? That was the name of the first episode. Maybe the second
Yeah.
name or the name of the second episode will be Why Kotlin great. But
Why Kotlin multi-platform great? Yes. Yeah. As we teased in the last episode, we're gonna look into platform channels,
yeah,
accessing native APIs, and see how that works. I think this will be the episode where we will see, somewhat more complicated code. We will also open up the native projects, see what is going on there, and maybe even see some Kotlin multi-platform code, maybe as comparison.
yeah. So let's
Let's see.
jump right into sharing the screen. So the topic is how can we write code that addresses native APIs? Let's say I want to use Bluetooth or locations. Most of the time, obviously, you would get some kind of Dart library, Flutter library that does that for you. So you have an ecosystem that allows you to do the most common platform related things. But some of the time you might want to just use one of the APIs, the platform APIs, something like from Android's context or from, I don't know, how are the Swift libraries typically called? Foundation, something like this.
Yeah, exactly.
Yeah.
Yeah, I think it makes sense. I opened up the project from the last video, and the last thing that we did, if I scroll down a little bit, we persisted the counter on the left, and let me just increase the device a little bit. We just had the default counter app that we can press, increase the counter. And the last thing that we did was persist it. And we used a plugin that is called Shared Preferences. And it just saves it on Android in Shared Preferences, and on iOS, it saves it in the NS user defaults. And I think we can maybe now open up the iOS project. We can also later on open up the Android Studio project and look into how the plugin is first of all integrated into the project, into our project, into our app. Then we can look at the source code, because we can theoretically also debug that source code. And then we will see how we can create our own little platform.
Yeah, that makes sense.
API.
So when you say plugin, you mean the shared preferences library that you pulled in with the,
yes.
How is it called? Pod spec is the file that you declare dependencies. So
Yeah,
here in the pod
spec
specs YAML, we see the dependency to, where is it? Shared preferences. We use version 2.2.3 in this case. And this brings in native code because it needs to go to actual Android's shared preferences and access those APIs. And how is it called? NS user defaults on iOS.
Exactly.
Okay.
Exactly. And yeah, I think let's just jump into the Xcode project and open up some files. So essentially what happens under the hood, maybe one last thing in the IntelliJ project, if we look at our dependency tree, we will see that shared preferences, can I increase it? It's maybe a little small, but we can see that shared preferences, the dependency shared preferences, pulls in a few more dependencies. So we have shared preferences Android, Foundation, Linux, a platform interface, and web. This is the typical structure for these platform plugins or packages. They have one platform interface. This is then the API that you use in your project, in your Dart project. And then for every target platform, or for most target platforms, you will create another package that will then contain a little bit of Dart, but mostly platform specific code. And this one is also now linked into our iOS project. And what Flutter does, and the toolchain does, is it adds this as a pod to your project. And you can actually look that up in Xcode if you want to. So here I opened up our counter app, the iOS project, and I opened up the development pods, and you will see that shared preferences foundation, which if we quickly go back, is this package right here. This one is a link to our iOS project. And if we then scroll down a little bit in the folder hierarchy, we will eventually see the corresponding Swift code. And here we can actually see all the methods that are implemented: get all, set bool, set double, set value, and so on and so forth. So this is how the native code from a package is actually linked to your project. And it's also compiled. So when I now run this, the Swift stuff here will be compiled. And I can also, if I want to debug anything, I can at any time just hit a breakpoint, run it from Xcode, and debug the stuff, which is kind of cool. Also, if you just want to learn how they implemented it for your own.
Okay, so I see some interesting things here. So it's called, like, the class here is called shared preferences plugin, and it implements Flutter plugin. But how does this work so that you, like, here you just have this function set bool, set double, set value, but at some point you want to call those functions from Dart. But how does the bridge work?
Yeah, this is I think in order to explain this, we will start to write our own plugin or our own function. And I can maybe, just to show you how this stuff works, I can maybe open up the one image from the documentation that explains it somewhat well, I would say. Whoops, I'm sorry for this. And in the documentation, they give you a very simplified version of the different layers. But what we have is we have our Flutter app and the engine. Here simplified by just Flutter app client. And this Flutter engine is then able to talk to, I would say, the native side. In that case, they call this the app delegate and the Flutter view controller, and on Android it's the activity and a Flutter view. And what we have to understand here, which we didn't previously discuss, is that essentially on iOS and on Android, you only have one single activity or one view controller, and this view controller has an instance of the engine, which is also responsible for drawing everything on the screen, but it's also able to communicate from your Dart code to your Swift code.
Okay. But it is scoped to this one particular view controller, meaning that the entire universe of your Flutter app lives in this view controller or in this Flutter view. I heard that some people talked about using Flutter for just implementing one shared view. Let's say you have a fancy animation, a fancy view, and I've been told that it is possible to have Flutter implement just this particular view, share it across the platforms. But would this then mean also that this particular view can then not communicate with other views that have been implemented using Flutter, because there's an isolation? This one view controller hosts your universe of this particular Flutter application.
So this structure is basically what comes out of the box if you create a new Flutter project. But if you want to do some custom stuff, like what you just mentioned, you're always able to just create a new instance of a Flutter engine in Swift, and then, for example, hold it in your app delegate and have another view that draws it. But you will eventually have some scoping. What I never did is have multiple views drawn by the same engine. Maybe technically that would work, but again, you just have one engine that also holds the state of your application. But you are somewhat flexible. So you can have your app delegate and your app runs, I would say, normally, and then you have one view controller that is using this global engine to draw something. And then if this view controller is popped and pushed again, you can still use the same engine and therefore hold the same state. Stuff like this is definitely possible. But again, you have to see your specific use case. For just one single view, spinning up a Flutter engine, I would call it somewhat overkill, but if you want to, go ahead.
I mean, I just recently learned that
works.
I think, what was it? Google Mail? No, I think, was it Google Mail? Some application that is not doing a lot. Maybe I'm sorry now because Google Mail does a lot. Maybe it does a lot, but it's just a mail client. And I've recently learned that it's like almost a gigabyte. So it's like, what the heck? Like, I'm not sure if it was Google Mail, but I think people probably are willing to accept like this kind of overkill.
Yeah, I think there are other success stories from popular games where they said, all right, we have parts of our application that just have to be like 2D UI, like a menu or something, and we just want to share this across all of the different targets we target, different platforms we target, and then you can have a Flutter engine running for your profile menu because your game is already quite big.
Yeah,
but also the Flutter engine is not too huge.
Yeah, I remember it was not Google Mail. It was Teams, and it was 2.3 gigabytes. And there was a funny tweet. So it's like, what the fuck is Microsoft doing? Are they shipping an entire operating system with Teams? But like, it's, I mean, how large is Windows? It's probably 4 or 5 gigabytes, and then they ship 2 gigabytes or more than 2 gigabytes for just this messenger. Like, I don't want to talk. Like, you.
You cannot talk yourself out of this right now.
Yeah, I see. Let's continue with Flutter.
Alrighty. So the key word that we see here is method channel. And this is also the API we're going to work with on the Dart side, and then in just a minute on iOS as well. I'm just doing iOS because I want to. We can do the same on Android as well. Alrighty. We can be somewhat flexible with our use case, what we want to fetch. I think we're going to do, I will just prepare some kind of hello world example, and then we can fetch whatever we want to. But we will start by declaring a method channel. And right now, of course, you would somehow scope this, create your own class, maybe something like shared preference plugin does. But we will just do it in our
let's go the simplest route. Like, we just want to call something from shared preferences ourselves. So method channel is something where we can call into, and somebody from the native platform will respond us with a value, right?
Yes, exactly. So we basically just create a method channel, and then we give it a name. This name we, of course, have to use on the native side as well. Just gonna go with hello.world.test. And then let's go to the increment counter method, and you can just invoke a method. And this method, we can also give a name that we then have to handle on the native side. I will just call it get value. And this returns a future, and we will get a result back. This is a very, we'll just print the result maybe.
Looking at it, that it seems to return a future. So I'm asking myself if all of those invocations to the platform side, are they always asynchronous, or is it just like, to simplify things, they always return futures, but if you do not do something asynchronous on the platform, it will basically return immediately. So it's a future, but you cannot wait. It will be available right away. There is no suspension. It will not be waiting for it for some time. How does this work? Is it always?
It's always a future, and it's also something that might, based on the use case, might be limiting. There are other plugins, for example, that I would not say work around this, but there are people, for example, using different ways to communicate with the native side, with people using Dart FFI. Again, somewhat niche use case for this, but essentially it's always a future. If we go the standard Flutter way, which we will do in this video, it's always going to be futures, always going to be asynchronous. And something also to note is that if we invoke this method channel, we can, of course, also pass some value to it. So I'm able, if I look at the method signature of invoke method, you can see that I have a second parameter, dynamic arguments. And
this, it looks very much like how you would, for example, use Java reflection. You pass, like you ask for the method by name. You know what the name of the method shall be, and then you get an instance of a method, and then you can just dynamically invoke it by passing some arguments, and it's somewhat unchecked at compile time, but will at runtime then blow up if you mess it up, which we do not do, right? We know what arguments our own methods want to have.
Yeah, of course. But it's somewhat similar. Like you expect the method to be there, you invoke it, and if not, it will of course blow up and fail. Something that we have to keep in mind is that whatever we pass to this has to be somewhat serialized. So there are some data types that they support out of the box, but if you have a bigger data structure, you will eventually end up passing down a JSON, for example.
Mm-hmm.
And then on the other side, you have to serialize it again and do whatever you do. There are plugins that automate this for you. So for example, the Share Preference plugin uses another tool called Pigeon that takes care of this for you. So it essentially generates some code that helps you do this. But again, we will, in this video, just do the basic vanilla Flutter way.
Yeah, makes sense.
All right.
Can we run this right now and just see how it would inform us that this method channel is not implemented?
Yeah, so again, we can just hot reload. I will open up the console so we can see what happens. And now if we press that button, we will get an exception.
Yeah, missing plugin exception. And
yeah.
Okay, is the term plugin here used specifically for things that bridge into the native platforms? Because like
yes,
usually like you previously also called the Share Preferences library a plugin. So is there this naming convention that every time you bridge into the native territories and like you use the platform APIs, you start talking about it as a plugin to Flutter?
Yeah, okay. Yeah, exactly. In most cases, package this plugin. Yeah, exactly. So now we get the exception.
Yeah.
We try to invoke get value on the channel hello world test. Didn't work. Now let's jump over to our iOS project and see where we can handle the call.
Yeah.
Very, very straightforward. I'm gonna be the guy that just copies a little bit of code, but I walk you through this and also explain you what it does.
Yeah.
But to have a starting point. So I'm gonna make some space here. Let's go through this line by line. As I told you before, the Flutter engine is, in our basic example, attached to our view controller. So what we essentially doing here is we're getting this view controller, and since we only should have only one root view controller, we are also just casting this as a Flutter view controller. This cast should always succeed. Of course, if you have custom stuff, not, but in our case, it will work. And then from that controller, we can get this binary messenger, which is from the engine, which will give us the ability to communicate with our Flutter engine. So we're setting this up. And here we are also using the method channel class. But now instead of invoking something, we will set a method call handler and wait for events, and then we can respond to this. We can also do this the other way around. So, for example, if I want to dispatch anything from my Swift side to my Dart side, I can also go in here, and if it compiles, we can also do an invoke method, which doesn't work, but we will give it a run, and then I will show you. But I can do the exact same thing. I can dispatch it here. And if I go back to my Dart code, I can also do a set method call handler.
So it's both. It's in both directions. So you can send a request from Swift side or Kotlin side to Dart, and Dart will respond. or you can like send the request from Dart side, and then the native platforms will respond to this request.
Yes.
Is it somewhat common to have the direction from the platform calling into Dart utilities and then Dart returning? Because I imagine you could do you could even go the route of using Flutter for not implementing the UI, but having some business logic being shared. Like that would work. You could just call into Dart code that does heavy lifting for you and then returns you some kind of serialized state of your application, and then use the native platforms to render the UI. Obviously, that's not why Flutter was invented, but you could do this. So I'm wondering how often this direction of platform code calling into Dart and requesting some computation from Dart, how often this is applied? Like, is it common to see this, or is it really niche?
I think it's not niche because I mean, of course, it always depends on the use case. But let's say you are just pushing information and events to your engine or to your Dart application. Something like, hey, whenever something changes with my, I don't know, nearby Bluetooth devices, invoke this method. Or if something changes in the location of the user, you can technically just push it to the Flutter side in that way. You can also wait for results to be returned. Haven't used that heavily, but this would be one use case. For like specifically locations, there's also another concept of a stream handler. So you literally have something that is built on top of a method channel that mimics a stream. So this would mean that if you subscribe to the stream, the method channel calls the native side and tells them, hey, someone listened to the stream. Now, please do anything that you have to do. So if we stick to the location example, it would request location permission and on the iOS side, listen for location changes. And then when a location change is delivered, it will then deliver a value to the Dart side. And if you cancel that stream, they will also cancel the location subscription
makes sense.
on iOS.
Oh, I see.
A little more advanced.
So the direction from the platform calling into Dart is to send some kind of events that arrive at the native platforms.
Yes.
Location is a perfect example. Like you get the location updates from your native platforms. They will call into native APIs telling you like, hey, the location changed. Like you moved 3 meters. Like, good job, mate. And then it will, then you will be able to just tell Dart like, hey, look at what I did. Like I moved 3 meters.
Exactly. And for those cases, perfect. Now going to your Frankenstein business logic sharing case. Yeah.
Which
technically possible. Maybe.
Which was for a long time the underlying or the idea for Kotlin multi-platform, where we wanted to shine the most, as in we did not have any UI framework, but we advertised that it is very easy to share the business logic, which it is, and we saw multiple companies picking it up and using this case. That's why I was so curious if this is also something done in Flutter, because obviously it's not designed for this, whereas Kotlin was designed for doing exactly this case first.
Yeah, I will give you a little example where it's quite tricky. I mean, maybe you can get this done, but I would say it's far away from being very easy to maintain and intuitive and nice. Just because, first of all, you have to serialize everything, so huge amounts of data would also already cause performance problems. Everything being asynchronous also is not super nice. And then if we dive into the whole, hey, I want to do stuff with different threads, this also gets a little tricky because the engine has its own thread, and then you want to go heavy on that. That's also a little tricky. And then what you maybe also want to have is maybe you want to, again, very specific on the use case, but imagine you have some class on your Swift side, like you maybe get an instance you get a list of tasks back, and every single task has an ID, and it also has a method. But this method is not implemented in the Swift task class, but it's implemented on the Dart side. Now you have to wire up a method channel for every single task, I assume. And then you have to somehow connect them. And now you suddenly managing instances on Swift side and also on Dart side.
It sounds like it gets complicated, because I see here that the method channel, you like the identifier for the method channel here in this case is hello world.test, right? There is not like, you do not have an instance that is shared across platform and a Dart. You need to match that up by matching the identifiers. So you have one method channel, hello world.test, and then there are methods and method handlers. Like you can invoke a method, you can add a method handler. But if you have this, like as you described it, like this many instances, and you would want to call methods that are associated with this instance, then you need to manage, like, okay, I'm calling this update task function, but it also needs to know which task to update. So either you add it as a parameter, or you have method channels for each task, as you said. So it can get tricky. Like it's certainly doable. Like if you wanted to make that work, I'm pretty sure you can find a way. And I'm also convinced that probably performance will not even be such huge of a problem, right? Because like computers are fast and stuff, you know.
Yeah, but you know how we like to optimize for performance, even though it's not a problem at all, because it's very nice to sell it.
Yeah.
And it's also very easy to win a debate with your performance sucks and be like, yeah, but is it a problem? Nah. At the end of the day, we're just building apps that do pretty print JSON. So, but anyways,
Anyways, let's see further how we would implement this method channel here. You showed me the Swift code, and I think from the Swift code there was like, when we wired up the method channels, we need to also like change now by declaring them a method channel instance. Yeah, now we changed the name to also match this hello world test. I'm not sure what the binary messenger here does, but I assume that this is like a way where you could call or like tell Flutter how you would want to serialize the data that is passed between Dart and Swift. So binary messenger here probably just serialized it to a convenient binary format, not using JSON.
We can look into the data serialization part in maybe after we implemented this, but right now it's basically this place is where we will write our code. So what we do in here is we can just, from a call, we can maybe compile it once. I will just do nothing, but I will just give it a run. And now we will also see it improve, at least there a message. But we should
is there even I think it will just never like the weight that we have, since we never return something in this. Oh no, wait a second. We return something, we just return void, right? From the method handler from Swift.
Yeah, I mean, I will not spoil it, but I like your thought process. So we essentially what we get is we get a call. We can get the method, like the name of the call in our case. If we look back, it should be
I have a second. Like I changed my prediction. Like, oh no, I saw it on screen now, not what happened, but I might change my prediction. I see that the method handler here, it gets the method, like this call, Flutter method call. I'm pretty sure like you will get the name, like where we call something like get value. So we can do here, we can now check if the method is get value, then do certain actions. But we also get this instance called Flutter result as a parameter. And I'm pretty sure here's where we should call a dot complete or complete with exception or something. Since we never do this, my prediction now here is the await that we have on Dart side will just never finish. Like it will await forever, because like, it assumes, it has no idea what the platform side is doing. It assumes that maybe this Flutter result is still somewhere out there trying to find its completion, or like poor Flutter result will never find its soulmate.
It will just
stay lonely forever.
Nobody will. It will never complete.
Yeah,
but essentially, that's absolutely right. So if you now click on this, you will see we're clicking, nothing gets incremented because this poor little guy is waiting for someone to complete him. And now we will be the ones that complete him. So please, export, don't let me down on this one. Yeah, now we're talking. All right. So we get our method call, and should we just print it? we're gonna just do, hey, if a method call is
get value,
we will just return with a result. And
now we can obviously do whatever we like, use NS defaults, but for the sake of simplicity, we can just say hello from Swift. Everybody will know what we can do from a Swift side here now. We have all the power we need.
And that's kind of the cool thing. We can also do asynchronous stuff in between, because we are totally free to call the result callback whenever we want to.
Yeah.
So yeah, that's basically how the stuff works. So for all the other method channels, method calls, we'll just not complete them.
How would we forward an exception? So if the get value fails, there's now this. I see you have this result method.
Yeah, I think there is on Android there's a .unimplemented or there's a constructor for this, but we can just put in a Flutter error.
Oh, I see. You return. Makes sense. You can have a code, a message, details.
Yeah. So we can just do, I don't know, code. We can have some specific error codes that we then also on the other side handle. We can do custom exceptions throwing, whatever.
Yeah, I see.
We just do anything. Details.
Which also means that, and maybe this happened to you from time to time. I'm curious about this. If you have this method channels and something goes wrong on the Swift side and there's an exception, you caught the exception, but the exception happened somewhere deep in the call stack. You caught it, you processed it, you logged it, sent it to whatever server to analyze. But then it's easy to forget that at some point you should have also forwarded this exception to this Flutter result. So does this happen from time to time that you're just looking at your application, you hit a button or something just never really finishes it? It's kind of seemingly stuck because it waits for a native platform call that had an exception, but you forgot to forward this exception. Is that a common mistake that Flutter devs can do?
I think so, especially if you have more complex plugins. And let's just say you have a good example is maybe on Android, you are doing some stuff with intents. You know, the good old nice intents.
Yeah.
You send an intent away, you get the response, but then now all of a sudden your plugin gets way more complicated because you have to, you're completely moving out of this method. You maybe send an intent here, then you have another callback in your main activity, wherever you get a result for the intent. And now you have to, complete this method call. So it gets way more complicated. And then of course you might be stuck not answering at all. Or something that also happens is that you don't catch exceptions well enough, and then your application just crashes. Because on Dart, it's somewhat, I would say, more forgiving. If there is an exception thrown, your application does not quit. We've seen this previously. Method channel was not implemented. Just get an exception, device and application just stays in the state.
Yeah, so there's probably this like loop, this application loop that processes events, and if it sees that, in my main loop there was an exception thrown, then it's lenient enough to say like, let's try to wait for the next loop, because maybe it was started by a user pressing on a button. The button press led to this exception, but maybe it's better to have the application not crash. And maybe if he presses another button, our app will work, because like, why wouldn't it?
I mean, to that behavior, there are ups and downsides. Sadly, I cannot tell you in detail how this works with the loop, but again, some people like it, some people absolutely hate it. It's from users' perspective also somewhat, sometimes quite, annoying. Like you click on a button and it tells you the button was pressed, like you get feedback, but then the exception throws, the user doesn't see it, and he just presses the button again and again and again, and nothing changes.
On the other hand, if the user presses the button and the app just closes, the user also has not really a good idea what happened.
Yeah, but it doesn't spam my sentry.
I see. Yeah, okay.
Okay, so the frustration is only on my side. Ups and downs. I to be honest, I like it because also during development, as soon as the application crashes, I cannot hot reload anymore. I cannot continue doing what I do. And that's an upside. I also don't lose state, because when you develop, which maybe is also a nice addition to the last episode, if you are making mistakes, if your application just crashes, it's annoying and brings you out of flow. So now we are responding to our platform channel. We will hit the button, and now we will get the hello from Swift printed out here in the console, which is kind of nice. We can also now change the method name, and now we should get
we should now see again that there's no such method handler.
No, because we are now throwing an exception in all other cases.
Oh, I see. You implemented that in Swift. There is now I see that in the method channel there is the call handler, but it does throw the exception. We saw that you wrote the code that if it's oh, okay, yeah.
This is, let's put it side to side. This is essentially what I did here. So if I don't know the method name of that call, I will respond with an error. But I think we should also be able to respond with an unimplemented error.
I'm just curious, why is there no else in that code? Because it seems to me that if the method is getValue, you call the result function, but you also will call the Flutter error, right?
Yeah, that's something that I forget. Very good catch. We finished the future call here. So this one will just silently, it will be invoked, but we don't.
Okay, so Flutter.
The future already completed.
There's no. I think I hope I'm correct here, but I think for Kotlin's completable future or like complete or deferred. How is it called? Deferred is, I think, the class called, like, this is the pendant to the completable future. If you would complete it and it was already completed, I think it will tell you with an exception that you should not do this.
I think it would be nice if we also get an exception here.
But here
maybe
it seems
I also missed it.
Yeah, but here it seems like Flutter just happily takes the first one, closes this Flutter result, and then future requests to resolve or complete this future will just be ignored because already done, and then it ties well to this overarching story of Flutter trying to be really lenient. It sees maybe there is something wrong here, but its best intention is here now to ignore the problem, in the sense that, like, let the user still have the app. Maybe it logs it to the console and says, like, hey, already completed this, but
I just while we were talking, I was starting the application on an Xcode. So here you can see it's running, and it opened up a new simulator. I can maybe close the other one. It started a new simulator. Of course, the Flutter engine in the background, the Flutter app in the background just annoyed and yelled at me. But what I want to show here is that I now set a breakpoint in my code. And now if we click on the button, we should hit the debugger.
Yeah.
And then we can also look into our call. I'm sadly not able to increase the size on this one, but what we can now see is that in the Swift, in the Xcode debugger, I can look into my Flutter method call object. I can see the value. I can see the arguments being empty. And now we can also just step over. We see we completed. And of course, as you said, we of course also hitting line 23 again. And then, just continue with this. And now for completion, something that I showed previously is we can also just go into our shared preferences plugin code, and now that the debugger is attached, we can also just hit a breakpoint there. I think we implemented I think it should be set value or set double. Is there a set int? Maybe not. We just hit the button, and now we can see. We can just, if we want to, debug that stuff. Exactly.
Yes. So should we look on how something like this would be done for Kotlin, because I think this is exactly where Kotlin shines, where like I think Flutter has a lot of positive sides when it comes to this developer experience on the hard reload and this like how fast you can iterate on that. I think Kotlin has a pretty nice point when it comes to like writing code for multiple platforms. I could just share my screen. So we are here in a like one of my hobby projects. It's a multi-platform application, and I think it makes the most sense to jump to the part that is also like displaying the application. You can see it here on the right, and I can just show how this would be done, like calling into native platform APIs from Kotlin side. So you see here, the interesting part is that there is already this common main sources, and then we have sources that are specifically for iOS, Apple, or Android. So I can share in a fine granular manner, like I can put source code somewhere and it says like, okay, here's everything I want to share across all the Apple targets. Here's something that is particularly just for iOS. And I can have some code that is written for common. And I think, what did we call, like, we can just have something like shared preferences.
Yeah, let's go shared preferences, because I think it's a very good example showing how easy and trivial it is to persist some value. And what of a boilerplate we have to write in Flutter instead.
Yeah, so here, like what you could do is like we can just say that we expect a function, which is, let's make it very similar to the example of Flutter that we had, where we just like called into this get value function. So in this case, I would also just call something like get value from shared preferences, and we return something like a string, for example. Well, string and optional. And of course, I cannot provide a body, because I expect this function to be implemented on the native side. So to look at this from a Flutter's perspective, I think this is not only creating the method channel, but also this like method invocation, where it's like what we previously had called get value would now be called like this method. It's like under this package. It's just a method. It will just get linked. And you can see that here I would now be able to provide missing actual declarations in IntelliJ. And I could now say, like, if you want to just stay with the same example and just implement this for Apple, you can see I could now also check the Android main and say, like, I want to implement this for Apple and Android. If I just create this for Apple, it automatically creates me this function, and it now says, actual function get value from shared preferences. And here I would be able to just return, I think, what did we return previously? Some hello world string. So
now, just 1 second. Maybe you can very, very quickly talk about how we, for example, from a common main code, or how does it work that we just call this NSUserDefaults class? Because here we are writing Kotlin, obviously, but now you have an import for foundation at NSUserDefaults without actually writing Swift.
Yeah, exactly.
I mean, for some people, this might be totally understandable, but maybe for Flutter folks watching, what stuff is happening?
That's a good point. So it is still Kotlin code that we write here, and yes, we are calling straight into the platform APIs, and we have this import platform foundation NSUserDefaults. And you might think that, oh, maybe we are just hiding this behind something very similar to method channels from Flutter, and we just auto-generated all of those method channels for you, and therefore you can call into platform. But what happens under the hood here is that we are able to call into this native APIs directly, because we are compiling the code for like the Kotlin code for the different platforms with even different compilers. So there is just one Dart compiler. Maybe there are more Dart compilers, because I know that there is like a Dart virtual machine and there's this ahead of time compiler. But in the end, like from the perspective of this recording or this conversation, there is one Dart compiler. It compiles your Dart code, and it has like the target is Dart, like whether or not it's the Dart VM or it's being like production code that also runs natively. It also is in the Dart runtime at least. So we can simplify it and say there's one Dart compiler. But there are multiple Kotlin compilers. There's a compiler that is Kotlin native, and it takes your Kotlin code. It runs the same compiler frontend, but it will then pass this, like it will from the Kotlin intermediate. It will create the LLVM IR and then passes the code straight to LLVM, which is the same toolchain that Swift uses. So when we do this, we can also make it interoperable with Swift directly, or in this case, still indirectly through Objective-C. So we are using Objective-C here to bridge the same platform APIs that you have. This NS user defaults is available for Objective-C. We can directly call into Objective-C APIs here. We're working on directly calling Swift APIs as well. So this will be available in, I think, a few months as a preview. Like, you know how it works. Like, probably it will take some time. But in the end, since we have a special compiler that here is now compiling all of this code as a native binary for iOS using LLVM, we get access to all of those APIs directly, which means that there is no in-between bridge. There's no serialization going on here. It's basically us just calling the native method. So in this case, we could even really easily call NSUser defaults, get the standard defaults, and help me here because I'm not a Swift or like iOS developer, but I think there's probably something like get value or something value. How?
Yeah.
Value for key.
Yeah, exactly. It's very straightforward. You said a lot of things. Now, I mean, how? Because for like Kotlin native is, I would say, at least for me, was not super straightforward to understand how that works. I mean, you now said some buzzwords like LLVM, IR, also intermediate representation, and all of these things. But I mean, I'm now compiling. Like I have my project now, and I'm now compiling this for iOS.
Yeah.
So essentially, again, I'm just simplifying things, and correct me. But it now takes the source code of the common main folder. It takes the source code of the Apple main folder and compiles it. And then at some point, we have to call NSUser defaults. And now, how does the linking work? I mean, I get a binary out of this.
Yeah.
And that binary is part of my iOS project. And now this binary has to somehow call the NSUser defaults API that is in my iOS SDK. So somehow it has to understand where to call that. I mean, is there some linking happening?
Yep.
How does that work?
Exactly. There's linking happening, and it will just use Xcode to build this. So first things that we built here, and I hope we can just like build the project and look into this. You see that I have some previous build failures because I messed stuff up. But we can see that what is being built here under the hood, it also uses like first the Kotlin native compiler, LLVM, and stuff like this. But it also can use Xcode and Xcode build. And we should see that if we look into the classes, we can see some K-libs being produced. Obviously, I cannot build here for the JVM, so the JVM compiler fails now because this expect function here is not implementing something for JVM, so it's not implemented. And here's one of the differences. Obviously, it is failing and validating this at compile time, whereas it's not implementing it's not failing at runtime if there's something missing. So there's not just a Klib that is produced. This contains if you look into this Klib, it basically contains this IR here that is containing this K and B files, which is like Kotlin native, and then like bodies, definitions, stuff like this, types. Those are protobufs that are containing like the Kotlin specific representation of things. And those can then be linked to frameworks. And you see that in the build folder here, there's like Fed framework, there's a release framework, and in the end, it is producing me a framework that I can just use in Xcode as any other framework as well. And in there, like you see that it has like the headers. You can now use the same code here straight in Xcode. So we can look into Xcode here, open that up. That's the same project. I don't think I have a lot of like code actually in Xcode. And it's, content view.
We can maybe just import the module and just, I don't know, use a data class or something that you have, just create an instance of it, just to see how the Swift side looks, how the library looks from the Swift side.
Yeah, we can see this already here on screen. There's like this view controller that is this iOS pacemaker view controller. We create that and we can basically import this PM. Maybe we can just create a function here, function playground. And then in there, since we have like the stuff, you can see that there is iOS pacemaker view controller. I'm not sure what the other, like, I think there should be something like a heart rate scale KT. All of those APIs are not refined for like being accessible from Swift because, as you see, I do all of the work in Kotlin. So I did not bother about renaming the KT part here. You can see like heart rate off and then range, like that. Those are just the same things that I have defined in my Kotlin code, and they are somewhat exported here. What other things do I have? Maybe there's even like the Bluetooth. Let's see if we can find some of the APIs from the app.
Maybe look at the Bluetooth implementation from the Kotlin side, because I think there we have a more complex example on how you work with those APIs. Just to go through this.
Yeah, definitely. So here's like the Bluetooth implementation. I have it called Bluetooth Core. And you see that I have like abstractions that are interfaces. Bluetooth is hard, and I have not yet seen any abstraction that is really easy to understand, and they're all somewhat ugly. Here's mine. Hate it or love it, but there's like this BLE central service and stuff like this. And in the end, there's like the same implementations on Apple main. And then there is like this Apple Central View Controller, and I'm straight up calling into Hardware Manager. Like I think this is just retaining this core Bluetooth Central Manager. Like I'm just calling straight into the APIs. You see, is some like everybody who worked with Bluetooth will know about code like this, where we wait for the state of the Bluetooth to be like core Bluetooth Central Manager state powered on. Like it's an enum, and this is how the enum looks now through for Kotlin, going through the Objective-C interop. So the enum is defined in CB Central Manager state, and then the enum would be called powered on, but here it's now called like this to be addressable from Kotlin. So overall, the magic here happens. I would say straight in this code where you can just use the native platforms from Kotlin. You can just write code, and if you would really want to, you can even write the same things in Swift and use the Kotlin code as a direct interop. And we would even have one IDE from JetBrains that is called Fleet, and Fleet would allow you to have the straight interop. Like where you can actually write the code next to each other. You can even cross refactor. So if you would use this function from Fleet's Swift code, and then you rename it, then it will be automatically renamed on.
That's very cool. That's very cool. I did some experiments with Kotlin multi-platform, and the use case that I was trying to implement is all of my business logic is written in Kotlin. So I have view models, and the UI is written on the native side. And that was quite cool because in your Swift UI component, you just create a view model, and you can just command click into it, and then from your Swift source code, you command click into this, and now you end up in a KT file. And that's quite cool. Like, hey, give me references, give me usages, and then it jumps back to the Swift side, and that's kind of cool. Same, you see a class from Swift side, and you want to rename it, and then it renames all the Swift occurrences, but also on the same side goes to your Kotlin files and takes care of that as well.
Yeah,
and that's very, very cool. And also, Of course, I'm a little fan, but it's quite mind-blowing if you come from a Flutter side. You've been writing platform channels for a long time, and then you just expect, let the tooling generate 2 files for you and implement them, and that is quite magical. And again, everything is synchronous. I think one of the examples, like a very simple example, was I want to generate a UUID. And for Dart, for example, we have packages and plugins for this that generate your UUID. But for Kotlin native, you don't really have to. You can, but you can just create a function on iOS, use NSUUID, on Android, JVM. There you go.
Yeah.
Something that is very, very different from like just after we've explained all of the things, something that is very, very different compared to Flutter, so Kotlin native compared to Flutter, is that in Kotlin native, you're actually caring more about the platform you're building on. And I don't mean that we ignored it in a negative way, but you are, in most cases, just writing your Dart code. And when you run your app, you're not really, or some, especially beginners, they don't really know what happens under the hood. Like, is there a Dart VM running? How is it compiled? Like, what is the difference between running an app in release mode versus debug mode? And then same for tests. We haven't talked about this yet, but tests, for example, also for Dart, you just execute them. Nice. For Kotlin, it's also a little different. Like, you write a test in common test.
Common test, yeah.
And then you will quickly find out, alrighty, I cannot just execute them. And of course, I can do this in Dart, but there's also a different approach to testing in Kotlin multi-platform that I like, where, you can also have excellent implementations and run your tests on JVM, iOS, macOS, and Android. That's also very cool. And for us, that's not so easy to do.
Yeah, right now it's like, I think the UX on how you would be able to run tests, especially if you would bring like macOS and Linux and stuff like this into the picture, can still be improved, and we're working on that for sure. But in the end, you can like define expect actuals for your tests as well, and make sure that you run like the assertions that you want to run on each platform with the testing capabilities of each platform. So yeah, I wouldn't know because I don't need to write tests, but
tests of people that make mistakes, and I don't make mistakes.
Exactly, you know that. So I think
amazing.
That's it for like comparing Flutter to Kotlin when it comes to bridging into native APIs. I thank you very much, Julian. This was a pleasure. And then
thank you for having me.
See you in the next one, I guess.
See ya.
Bye-bye.
Bye.